Now, welcome back to Apostle 1 tutorial. Yes, if today is the first time you are visiting my channel, make sure you tap on the subscribe button. Yes, tap on the bell and then put the notification bell on all notifications so that anytime I upload the video, you'll be the first person to get it. Yes. Now, let's look at this particular question. Now, previous video we talked about indices. Yes, and at this point, I'm coming to solve some small questions on the indices. Now, if you look at this particular first question, it was part of the previous, it was part of the try question in the previous question. Yeah. So I'm going to solve this one and then solve this particular question. Now let's start. Let's start with the first one. Now we have 2 exponent 3n plus 1, 2 exponent 2n, now we have a question like this, and then you know that from our previous lesson, I talked about how you can solve this. What we have to do is to break all of them down. We have 2 exponent 3n plus 1. And then you know that per the law of indices, if I have m plus m exponent s plus y, it means that previously they are multiplying. It means we have m exponent x multiplying m exponent what? M exponent y. So I need to break all of them down. Then we do substitution. Now, so which means this one is the same as 2 exponent 3n multiplying the base of 2 having an exponent of 1. Now we have 2 exponent n, 2 exponent 2n plus 2n. Now this one also means that we have another base having an exponent of 1, and then that addition means multiplication of bases. So 2 exponent 1 now is equal to 2 exponent n. Now this particular point from the previous video, what we did was that we did substitute so that it will make the calculation very simple. Now, so if we want to do the substitution, what do we do? This one is the same as 2 exponent n all exponent 3. Just like if you have m exponent n x, this one is the same as m exponent n all multiplied by x. So whether like this or like this, they are all the same thing. Yes, so that is what I am applying here. Now, so at this point, we have times 2. Now, minus this one is the same as 3 multiplying 2 exponent n. So I'm separating all the 2 exponent n so that we'll do substitution. Now, plus we have 2 exponent n here, multiplying 2 exponent 1, which is 2, then we have 2 exponent n. So at this point, what I'm going to do is that I'm going to use a variable to represent 2 exponent n so that to make the calculation very simple. So I have let m be equal to 2 exponent n. It means where I see m, where I see 2 exponent n, I'm going to replace it with what? With m. Yes, you know this one is indices leading to quadratic equation. Don't forget. Now, so let's replace all of them with m. Now, so 2 exponent n is the same as m. So m exponent 3 will give us m cubed. Multiplying 2 here. Now, minus we have 3. The whole of this one is m, and it is squared. We have m exponent 2. Now, plus we have 2 exponent n, which is the m. So we have the m multiplying the 2 and equal to 2 exponent n, which is now m. So let me multiply to get my quadratic. M exponent 3 times 2 gives us 2m exponent 3. This one will give us 3m squared. M times 2 will give us 2m. Now equal to m. Now at this point, what I can do is to group like terms. Since this one is leading to cubic, let me group all of them to one side of the equation. So at this side, I have 2 exponent m exponent 3 minus 3 m exponent 2. Then I have 2m. This m will cross the equal to sign to become negative. So I have 2m minus m equal to 0. Now at this point, these ones are like terms. Let me add it. So we have 2 exponent m minus 3m squared plus 2m minus m will give us m equal to 0. Now at this point, I need to factorize this one. Now this one is a cubic function. But since we have m is common to all of them. So the first factorization is I'm going to factorize m out. Now when I factorize m out, this particular term will be 2 exponent m squared. Now this side, m will cancel one of the m, I'm going to get 3m. M will cancel m, I'm going to get 1 equal to 0. Now, we need to get 3 answers for m because of the cubic function. Now at this point, I need to factorize what is inside the bracket here, and this one is quadratic equation, so everybody knows how to factorize. It's not now that I'm going to teach how to do this factorization. Now, how do you factorize? I have to use two numbers, which is negative 2 and negative 1. So I'm going to get 2m squared minus 2m minus m plus 1. We are factorizing. So I have m. When you factorize this one and this one, I'm going to get what? Okay, so let me put them in the bracket. M squared minus 2m in one bracket minus m minus 1 in another bracket. I'm grouping this 4 terms into 2. That is like 1. Now at this point, you can now factorize. Now what is common here is 2m. Now this side we're left with m minus 1. Only 1 is common to this one. So we have 1 m minus 1 equal to 0. So which means the final factorization will be I further factorize. So this one will give us m minus n, m minus 1, and then I'll take this one and this one, which will give us 2m minus 1 equal to 0. Now we are not done. I'm done factorizing this one. Let me clean this part. Now at this point, since m times this one is given as 0, then it means that the first one, either m is equal to 0, this one is equal to 0, this one is equal to 0. So you have to equate all the factors to 0. So the first one will be m is equal to 0. The second one will be take the second factor, that is m minus 1 equal to 0. Then you solve for m will give us 1. And the third one is you take the third factor, that is 2m minus 1 equal to 0. Then you're going to get 2m is equal to 1. Then m will give us 1 out of 2. Now, at this point, we are getting 3 answers for m. In the question, we were asked to solve for n, not m. But don't forget our substitution. We stated that let m be equal to 2 exponent n. So what I'm going to do is I'm going to quote that statement. Now when m is equal to 0, don't forget that I'm taking the first answer, m is equal to 0. Don't forget that m is equal to 2 exponent n. So I need to replace this one by m. So we're going to have what? 0 is equal to 2 exponent n. Now at this point, there is no way we can solve this. There is no way we can make the basis be the same. There is no way. And one way we can also solve this one is that we can introduce logarithm. And then we don't have logarithm of 0. So therefore, this one has no solution. This one has no solution. So m is equal to 0 is not an answer. Because there's no way we can convert this one from the base to the 2. And then when you introduce logarithm, we don't have log of 0. Log of 0 will give you marked error. Log of any number is supposed to be between 1 and then supposed to be in between 0 and then 1. So it's supposed to be greater than 0 but less than 1. We'll work for that. But when it is 0, the negative number, it will not work. Log of any number is supposed to be 1 or more than 1. Yes, I will talk about it in logarithm. Now, so let me take the second answer when m is equal to 1. So with the same preamble, m is equal to 2 exponent n. Now the m is 1, so this one is equal to 2 exponent n. Now, you know that this one is having a base of 2, and we can convert 1 to base of 2. 1 is the same as 2 exponent 0. So at this point, since the base are the same, it means the exponents are the same. So the first answer for n is equal to 0. And let me talk about the second answer for m. Now let me consider the second answer when m is equal to 1 out of 2. But you know that m is equal to 2 exponent n. Now the m here is 1 out of 2, so let's substitute. We have 1 out of 2 is equal to 2 exponent n. Now at this point, don't forget we have to apply our inverse rule. 1 out of 2 is the same as 2 exponent negative 1. 2 exponent n. Now since the base are the same, between the exponents are the same, so we have n is equal to negative 1. So therefore we have two answers for n. N is equal to negative 1 or 0. Or 0. So it's very simple as that. Now let's take another question. Now I'm going to solve this question in the next video.